considering whether to switch the neutral or leave it solid in a 3-phase, 4-wire, 277/480 volt transfer switch installation involves weighing several factors. Switching the neutral offers distinct advantages. Firstly, improved safety is achieved because switching the neutral ensures the entire circuit is de-energized during a transfer, reducing the risk of electrical shock or short circuits. Secondly, reduced harmonics are seen. When the neutral is left solid, harmonic currents can flow between the normal and emergency sources, potentially causing equipment damage. Switching the neutral eliminates this issue. Thirdly, voltage balancing can be achieved. In cases where the normal and emergency sources have different voltages, switching the neutral helps to balance the voltage from the loads. However, switching the neutral also has disadvantages. Firstly, complexity and cost increase because 4-pole transfer switches are more complex and expensive than 3-pole switches. Secondly, the potential for nuisance tripping exists because if the neutral is not properly grounded, it can cause nuisance tripping of the transfer switch. Thirdly, increased maintenance is required because 4-pole switches require more maintenance than 3-pole switches as they have additional moving parts. Leaving the neutral solid also presents a different set of pros and cons. Firstly, simplified design and cost savings are seen because 3-pole transfer switches are simpler and less expensive than 4-pole switches. Secondly, reduced maintenance is achieved because 3-pole switches have fewer moving parts, making them more reliable and easier to maintain. Thirdly, elimination of nuisance tripping is possible because with this solid neutral, there is no potential for nuisance tripping due to improper grounding. The decision of whether to switch the neutral or leave it solid depends on the specific application and requirements. In general, switching the neutral is recommended for safety and reliability, but it comes with increased complexity and cost. Leaving the neutral solid may be a more economical and practical option in certain situations. The National Electrical Code, or NEC, requires that the neutral be switched in certain applications, such as generator installations where the standby source is not grounded. Local codes and regulations may have specific requirements regarding neutral switching. The equipment being connected should be considered. Some equipment may require a switched neutral for proper operation. It's essential to consult the NEC and local codes to ensure compliance. Section 700.10. 3 of the NEC addresses transfer equipment, and it is important to consult the latest version of the NEC for specific requirements. Consider a scenario where a hospital is installing a backup generator system. Due to the critical nature of the loads and the potential for harmonic currents from sensitive medical equipment, switching the neutral would likely be the preferred approach. This would ensure that the entire circuit is de-energized during a transfer, reducing the risk of electrical shock or short circuits, and that harmonic currents are minimized, protecting the equipment. However, in a less critical application, such as a small office building with mainly lighting and receptacle loads, leaving the neutral solid might be an acceptable option. This would simplify the design, reduce the costs, and eliminate the potential for nuisance tripping. Remember that proper grounding is crucial in either scenario. If the neutral is switched, it must be properly grounded to prevent voltage imbalances and ensure proper operation of the transfer switch. If the neutral is left solid, the grounding system must be robust enough to handle any fault currents. When selecting a transfer switch, consider the voltage and current ratings, the number of poles, the type of transfer mechanism, and the control features. Ensure that the transfer switch is listed by a recognized testing laboratory such as Underwriters Laboratories or all, and that it meets all applicable standards. Regularly inspect and test the transfer switch to ensure that it is operating properly. This includes checking the contacts, the wiring, and the control system. Replace any worn or damaged parts promptly. Consult with a qualified electrical engineer to determine the best approach for your specific application. They can help you to assess the risks and benefits of switching the neutral versus leaving it solid and to select the appropriate transfer switch for your needs. Harmonic currents are currents with frequencies that are integer multiples of the fundamental frequency, which is typically 60 Hz in the United States. These currents can be generated by nonlinear loads, such as electronic devices, variable frequency drives, and uninterruptible power supplies. Harmonic currents can cause a variety of problems, including overheating of transformers and conductors, voltage distortion, and equipment malfunction. Switching the neutral can help to reduce harmonic currents by preventing them from flowing between the normal and emergency sources. Voltage balancing is the process of ensuring that the voltage on all three phases of a three-phase system is equal. Voltage imbalances can be caused by a variety of factors, including uneven loading, unbalanced sources, and faulty equipment. Voltage imbalances can cause a variety of problems, including motor overheating, reduced equipment life, and increased energy consumption. Switching the neutral can help to balance the voltage on the lows by providing a separate neutral path for each phase. Nuisance tripping is the unintentional tripping of a circuit breaker or other protective device. Nuisance tripping can be caused by a variety of factors, including ground faults, overloads, and voltage fluctuations. Switching the neutral can sometimes cause nuisance tripping if the neutral is not properly grounded. This is because the neutral can become charged with voltage, which can cause the transfer switch to trip. Grounding is the process of connecting an electrical circuit to the earth. Grounding is essential for safety because it provides a path for fault currents to flow to the ground, which can help to prevent electrical shock. Grounding is also important for proper operation of electrical equipment because it helps to stabilize the voltage and prevent noise. There are two main types of grounding systems: solidly grounded and impedance grounded. In a solidly grounded system, the neutral is connected directly to the earth. In an impedance grounded system, the neutral is connected to the earth through a resistor or other impedance. The choice of grounding system depends on the specific application and the desired level of protection. When working with electrical equipment, always follow safe work practices. Wear appropriate personal protective equipment, such as gloves and eye protection, to energize the circuit before working on it. Use a qualified electrician for all electrical work. The NEC is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years and is adopted by most states and local jurisdictions in the United States. The NEC covers a wide range of topics, including grounding, wiring methods, overcurrent protection, and equipment installation. It is essential to be familiar with the NEC when working with electrical equipment. In addition to the NEC, there may be other applicable codes and standards, such as those issued by the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or ALL. Be sure to comply with all applicable codes and standards. Transfer switches are used to transfer power from a normal source to an emergency source. They are commonly used in hospitals, data centers, and other critical facilities. There are two main types of transfer switches: automatic and manual. Automatic transfer switches automatically transfer power when the normal source fails. Manual transfer switches require manual operation to transfer power. The choice of transfer switch depends on the specific application and the desired level of reliability. When selecting a transfer switch, consider the following factors: voltage rating, current rating, number of poles, type of transfer mechanism, and control features. Ensure that the transfer switch is listed by a recognized testing laboratory such as UL and that it meets all applicable standards. Regularly inspect and test the transfer switch to ensure that it is operating properly. This includes checking the contacts, the wiring, and the control system. Replace any worn or damaged parts promptly. It's always best to consult with a qualified electrical engineer to determine the best approach for your specific application. They can help you to assess the risks and benefits of switching the neutral versus leaving it solid and to select the appropriate transfer switch for your needs. Furthermore, consider the specific loads that will be connected to the transfer switch. Some loads, such as electronic equipment, may be more sensitive to voltage fluctuations and harmonic currents than others. In these cases, switching the neutral may be the preferred option. Other loads, such as lighting and heating, may be less sensitive to these issues, and leaving the neutral solid may be an acceptable option. The type of emergency source should also be considered. If the emergency source is a generator, it may be necessary to switch the neutral to comply with the NEC. If the emergency source is a utility feed, switching the neutral may not be required. The overall design of the electrical system should also be considered. The grounding system, the wiring methods, and the overcurrent protection should all be coordinated to ensure that the system is safe and reliable. Switching the neutral can have an impact on the grounding system, so it is important to carefully consider the grounding implications before making a decision. In some cases, it may be necessary to install a separate grounding electrode system for the emergency source. The cost of switching the neutral should also be considered. 4-pole transfer switches are generally more expensive than 3-pole transfer switches. The cost of the additional wiring and grounding equipment should also be taken into account. In some cases, the cost of switching the neutral may outweigh the benefit. The maintenance requirements of switching the neutral should also be considered. 4-pole transfer switches generally require more maintenance than 3-pole transfer switches. The additional contacts and moving parts can be more prone to failure. In some cases, the increased maintenance requirements may outweigh the benefits. The potential for nuisance tripping should also be considered. Switching the neutral can sometimes cause nuisance tripping if the neutral is not properly grounded. This can be a significant problem in critical facilities where power outages can have serious consequences. In some cases, it may be necessary to install a ground fault protection system to prevent nuisance tripping. It is important to carefully consider all of these factors before making a decision about whether to switch the neutral or leave it solid. There is no one-size-fits-all answer. The best approach depends on the specific application and the specific requirements. Always consult with a qualified electrical engineer to determine the best approach for your specific application. Remember to periodically review your installation and ensure that it continues to meet the evolving needs of your facility and complies with the latest codes and standards. Continuous monitoring and proactive maintenance are key to ensuring the long-term reliability and safety of your electrical system. Always prioritize safety when working with electrical systems. Electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and other hazards. If you are not qualified to work on electrical equipment, hire a qualified electrician. By understanding the pros and cons of switching the neutral versus leaving it solid, and by considering all of the relevant factors, you can make an informed decision that will ensure the safety and reliability of your electrical system. Also consider future expansion. If you anticipate adding more loads to the system in the future, it may be wise to switch the neutral to accommodate the increased harmonic currents and voltage imbalances. This can save you the cost and hassle of having to upgrade the transfer switch later on. Consider the environmental conditions in which the transfer switch will be operating. If the transfer switch will be exposed to harsh conditions, such as extreme temperatures, humidity, or dust, it may be necessary to choose a more robust transfer switch with a higher environmental rating. Consider the availability of spare parts and service. It is important to choose a transfer switch from a reputable manufacturer that offers good support and service. This will ensure that you can get the parts and service you need to keep your transfer switch operating properly. Before making a final decision, get quotes from several different manufacturers and compare their products and services. Be sure to ask about the warranty, the lead time, and the installation costs. This will help you to get the best value for your money. Finally, remember that the decision of whether to switch the neutral or leave it solid is not always a clear-cut one. There are many factors to consider, and the best approach may vary depending on the specific application. If you are unsure of what to do, it is always best to consult with a qualified electrical engineer. They can help you to assess your needs and to choose the best transfer switch for your situation. Remember to always follow the manufacturer's instructions for installation, operation, and maintenance. This will help to ensure that the transfer switch operates safely and reliably for many years to come. Switching the neutral offers more than just safety, it can also improve power quality. By preventing harmonic currents from circulating between the normal and emergency sources, you can reduce voltage distortion and improve the overall efficiency of your electrical system. This can lead to lower energy costs and extended equipment life. Leaving the neutral solid can be a cost-effective option, but it is important to be aware of the potential risks. If you choose to leave the neutral solid, make sure that the grounding system is robust enough to handle any fault currents and that the loads are not sensitive to voltage fluctuations or harmonic currents. The neutral ground bond is a critical component of the grounding system. In a solidly grounded system, the neutral is bonded to the ground at the service entrance. This bond provides a low impedance path for fault currents to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. In an impedance-grounded system, the neutral is bonded to the ground through a resistor or other impedance. This impedance limits the amount of fault current that can flow, which can help to reduce the risk of arc flash. The location of the neutral ground bond is also important. It should be located as close as possible to the service entrance. This will help to minimize the voltage drop on the neutral conductor and to reduce the risk of noise. Consider the impact of switching the neutral on other equipment in the electrical system. For example, if you have surge protective devices or SPDs installed, switching the neutral may affect their performance. SPD are designed to protect equipment from voltage surges. They work by diverting the surge current to the ground. If the neutral is switched, the surge current may not be able to flow to the ground, which could damage the equipment. If you are using SPD, consult with the manufacturer to determine whether it is necessary to install a separate SPD for the emergency source. This will help to ensure that the equipment is protected from voltage surges even when the neutral is switched. Consider the impact of switching the neutral on the communications systems. If you have sensitive communications equipment, switching the neutral may affect its performance. Communications equipment is often grounded to the neutral conductor. If the neutral is switched, the communications equipment may lose its ground connection, which could cause it to malfunction. If you are using communications equipment, consult with the manufacturer to determine whether it is necessary to install a separate ground connection for the communications equipment. This will help to ensure that the communications equipment operates properly, even when the neutral is switched. The National Electrical Manufacturers Association, or NEMA, publishes standards for electrical equipment, including transfer switches. NEMA standards provide guidance on the design, construction, and testing of electrical equipment. When selecting a transfer switch, look for one that meets NEMA standards. This will help to ensure that the transfer switch is safe and reliable. The Institute of Electrical and Electronics Engineers, or IEE, publishes standards for electrical engineering. IEE standards provide guidance on the design, installation, and operation of electrical systems. When designing an electrical system with a transfer switch, consult with IEE standards. This will help to ensure that the system is safe and reliable. The NFPA publishes codes and standards for fire safety. NFPA codes and standards provide guidance on the prevention and control of fires. When installing a transfer switch, consult with NFPA codes and standards. This will help to ensure that the installation is safe and that it complies with all applicable regulations. In summary, the decision of whether to switch the neutral or leave it solid in a transfer switch installation is complex and requires careful consideration of numerous factors. By weighing the pros and cons, consulting with qualified professionals, and adhering to relevant codes and standards, you can make an informed decision that prioritizes safety, reliability, and the specific needs of your application.